Hello everyone, welcome to Geeky Nerd. Today we will begin with the part 4 video of time, speed and distance, that is relative speed. Before moving into the video, I hope everyone would have become thorough with the previous videos related to this topic. If you have not seen them, click on the card or the links in the bio to watch. In this video, we will deal with the definition of relative speed and the prerequisites to be considered before calculating the relative speed. Like, share, and subscribe the channel for more interesting concepts and shortcut methods for solving them. Let's move into the video. Relative speed is referred to as speed of one object with regards to the position of the other. The term relative means comparison. Here, relative speed refers to the speed of object A, and this speed depends upon the position of the object B. That is, when two objects move towards each other, we can calculate the relative speed, and when two objects move in opposite direction to each other, we can calculate relative speed. So the first case is when two objects move in the same direction, and the second case is when two objects move in the opposite direction. When two objects A and B move in the same direction, then the relative speed is given as relative speed is equal to speed of object 1 difference of speed of object 2. When two objects A and B move in the opposite direction, then the relative speed is given as relative speed is equal to speed of A, that is object 1, plus speed of B. Here, you may have a doubt that why when the object move in the same direction we are subtracting the speeds, and when they move in the opposite direction why we are adding the speeds. This refers to the theory of relativity. In physics, theory of relativity states that when two objects approach each other, their distance decreases. We know that when time remains constant, distance is directly proportional to speed. Therefore, when two objects approach each other, the distance between the two objects decreases. Therefore, the speed has to reduce. Hence, we use speed of A minus speed of B in the case when two objects move in the same direction. When two objects move in opposite direction with respect to each other, then the distance between the two objects increases. In this case also, time taken remains constant. When time remains constant, we had seen in the first video that distance traveled is directly proportional to the speed. Therefore, as the distance between the two objects increases, the relative speed also gets additive. So this is the best explanation of why you are subtracting the speeds to obtain relative speed when two objects are moving in the same direction, and why the relative speed becomes additive in nature when two objects move in the opposite direction. Let us solve some of the simple examples to understand how this works in reality. A train is traveling from a station A to another station B at a speed of 60 km per hour. Another train is traveling at a speed of 30 km per hour from station B to station A. The relative speed of train A with respect to B is. So from the question, we can clearly see that speed of train A is equal to 60 km per hour, and speed of train B is equal to 30 km per hour. It is given in the question that train A is traveling from station A to B and train B is traveling from station B to A. From the question, we can clearly understand that both the trains are traveling in opposite direction. That is, both the trains travel in opposite directions. We know as per the concept of relative speed, when both the trains travel opposite to each other, relative speed becomes additive in nature. That is, relative speed is equal to speed of train A plus speed of train B, which is equivalent to 60 plus 30, which is equivalent to 90 kilometer per hour. Had the trains traveled in the same direction, the relative speed would have reduced. That is, speed of train A minus speed of train B, which is equal to 60 minus 30, which is equal to 30 kilometer per hour. We had already seen why we are adding the individual speeds when trains travel in opposite direction, and why we are subtracting the speeds when trains travel in the same direction. Let us move on to the next question. Two persons are running from the same place at the speed of 9 km per hour and 6 km per hour. Find the distance between them after 12 minutes if they are moving in the opposite directions. So it has been given that speed of person 1 is equal to 9 km per hour and speed of person 2 is equal to 6 km per hour. So it has been given in the question that both person move opposite, I'm sorry, with respect to each other. So when two objects or person or anything move opposite with respect to each other, the relative speed increases. Therefore, 9 plus 6 will give us 15 km per hour. We need to know the distance between them after 12 minutes. Therefore, distance is equal to speed into time, which is equal to 15 multiplied by 12 minutes can be written as 1 by 5th of the hour, which is equal to 3 kilometers. Therefore, the relative speed between the two persons is equal to 15 km per hour, and the distance between them after 12 minutes is equal to 15 into 1 by 5, that is speed into time taken. Here 12 minutes can be represented as 1 by 5th of the hour. Therefore, distance is equal to 15 into 1/5, which is equal to 3 km per hour. So, with these two examples, we could have clearly understood that when two objects approach each other, the relative speed decreases, and when two objects move in opposite direction with respect to each other, the relative speed increases. In this video, we learned the definition of the term relative speed. We also understood how the relative speed varies depending upon the direction of travel of the objects. Problems were solved via both the shortcuts and the traditional methods. Viewers can choose any method depending upon their convenience. I insist all the listeners to practice solving more and more problems to increase their confidence. Like, share, and subscribe the channel and convey it to your friends so that they can be benefited. Until we meet in the next video, thank you.